Eric Kaiser is our next speaker. So he's going to be talking about analytics for cloud workloads, which we're super excited about. I think this is actually a perfect way to wrap up the day, as Tala this morning, right out of the gate, mentioned osquery a couple of times in his discussion, and how HashiCorp is using that for configuration management and inventory and kind of identifying anomalies on their machines. And I can't count how many times I've talked to people about osquery, and the conversation has come up where someone has said, is there any way to do the same thing for cloud resources? And I remember, looking at Cloud Mapper very early on, and it kind of started with that inventory perspective and eventually moved to audit and compliance. So Eric, I'm really looking forward to your talk about some of these osquery extensions that can give us some visibility into cloud infrastructure and our Kubernetes resources that we have for running. So feel free to go ahead and share your slides, take it away, and it's all yours.
All right, great. Eric, introducing Eric, thanks so much for that warm introduction. I want to make sure that everybody can see my screen. Is that coming through okay?
Yeah,
all right.
That's perfect. Looks
fantastic.
Great.
So welcome to Structured Security Analytics for Cloud Workloads, also known as Select Star for the Modern Attack Surface. Quick agenda. We're going to go over our agenda. I'll tell you a little bit about myself. We'll talk about some of the cloud security and visibility challenges, also known as why the heck you would even care about this. Although if you're here, hopefully you have an idea. Structured telemetry, sort of an introduction to what that is and how that can work to be a whole picture. A brief overview and introduction to osquery, the same for CloudQuery, and the same for KubeQuery. Then, if the fates smile on me, we'll have a live quick demo, and then a wrap-up Q&A, all the rest. So I'm Eric. I'm actually relatively new to InfoSec. I've been here just about 4 years. I've pivoted careers probably 3 times at this point. I play defense or blue team. I'm endpoint and cloud security internal to Optics. I have a OS system level security focus, and for my spare time, I like riding and wrenching motorcycles because giving presentations at conferences isn't hair raising enough. Also, I go by Magneto. If you see that picture online, that's me usually, especially when it relates to security. So let's talk about some cloud security and observability challenges. This graph from the SANS 2020 CloudSec survey gives a pretty high level overview as to some of the challenges that people have identified, right? Visibility into and control over sensitive data processed, but also almost as high consistent security controls, policies, access, and cloud on premises. Maintaining compliance is also very difficult, unless you are absolutely rigorous about your cloud hygiene and Terraform and redeploying services every time a configuration changes. It's very easy for configurations to drift and therefore your organization or pieces of it to fall out of compliance. So the biggest cloud security observability challenges are siloed tools and data, right? There's been a huge explosion of native cloud services and tools across multiple clouds, even multiple AWS accounts inside your organization, let alone hybrid cloud where you might have on-premise and cloud infrastructure. So this is from the Cloud Pegboard. They use AWS namespaces as a stand-in for AWS services. The growth in namespaces roughly correlates to the growth in AWS services. At last count, when I pulled the numbers for this slide, which may be a few months old, AWS had 283 separate services. That's no surprise to anybody. There's a lot out there, as we saw even in the previous talk. It's easy to sort of wander into the weeds of AWS and get lost. But Azure and GCP have almost as many, 261, right? And GCP has 115, but even though that's a third, roughly, of AWS, that's still nothing to sneeze at. You can't look at that individually, piece by piece. You need something that needs to cover the whole spectrum. So let's talk about the modern attack surface, because there's even more to that than just the cloud, right? You have your traditional infrastructure, workloads that might be dynamic or ephemeral, endpoints, containers, whether that's Kubernetes directly, OpenShift, Cryo, GKE in the cloud, cloud workloads themselves, AWS, Azure, all of the services that you're running. Maybe you're running containers inside the cloud, so you've got multiple pieces of the stack, but also SaaS apps, right? G Suite, Office 365, Azure, GitHub, whatever your file sharing solution is, if that's Dropbox, and even your identity providers, right? Okta, G Suite, Auth0, Duo. And so there's no signs of that slowing, right? The pieces that we add are only going to get more complex. We're only going to introduce entirely new workloads, entirely new areas that we have to monitor and secure. Additionally, with the shift last year, the major shift last year, but the other shift that's showing no signs of slowing is the bring your own device and work from home. So, we've seen the acceleration of like end-to-end IT managed endpoints going away, and you need to be able to monitor and control everything from devices that people are bringing all the way up to workloads in the cloud and the SaaS apps that you've got. So structured security analytics hopes, I say hopes because we're not quite there yet, but we're working on it, hopes to bring the power of osquery, as Eric mentioned, to the cloud, right? osquery traditionally covers what you would think of as endpoints or individual pieces, hosts, virtual machines, and even containers, though they might be ephemeral. You can run osquery inside them to get some visibility. KubeQuery extends the idea and power of osquery to container orchestration visibility. Again, if you want container visibility, that's where osquery comes in. But KubeQuery allows you to get a picture of your container orchestrator, whatever that might be, using the orchestrator APIs to be able to turn that into SQL tables that you can query. CloudQuery does the same thing for provider visibility. That's AWS, GCP, and Azure. Those are the big three, and those are fairly well supported by CloudQuery. We'll talk about some of the tables there. We're hoping to, although we haven't yet, and I don't have an ETA, to extend the power of those structured security analytics to SaaSquery, to be able to use the SaaS provider APIs to get information and put that into tables. And the same for identity query. That's identity provider visibility. Again, being able to use APIs that exist there, transforming that data into something that you can write queries against. So the vision here is to take all of the various pieces and very distant workloads and security tooling that you might have and bring that into a single structure, in this case, SQL tables. I am also aware that this meme probably dates me horribly, but when I was searching for funny SQL memes to put into my slides, this was the first one that came up, and it was so perfect I couldn't resist. So the question is, why would you do this, right? Why would you bother taking all of this JSON data or other things that are coming back from these APIs and turn it into SQL tables? Well, again, as Eric mentioned in the introduction, there is a demand for that. And the biggest ones that we've heard and seen are you can use your security team's existing familiarity with SQL to take the knowledge that's in their head, the ways that they think about detections, the ways that they are thinking about how data works, and apply that same logic and that same knowledge to various different workloads, since the structure of that data has been normalized, right? It allows you to lessen the impact of unfamiliarity with attack surface data sources. And most importantly, it allows you to structure queries similarly across heterogeneous OS and cloud platforms. So you can select star from various tables and join across things like AWS and endpoint data tables. So a quick introduction to osquery. For those who aren't familiar, it is performant endpoint visibility, as the open source project notes. It was open sourced by Facebook in 2014, and it was brought on by the Linux Foundation in 2019. It supports macOS, Linux, Windows. I believe it also supports FreeBSD and HPAIX if you really need it, but it does have good coverage for the big three. It has low resource utilization, which is great, and it structures endpoint telemetry as SQL tables for querying. It takes endpoint like operating system APIs. It can take files on disk. It can take log data and turn that all into a database that can be queried. Some pretty common use cases for this are endpoint detection, though not response, investigation and threat hunting. If you have an incident, osquery allows you to not only ask questions in real time, but keep historical data. And audit and compliance, being able to ask questions, again, not only of endpoints in real time, but asking those questions over and over again. What is the state of my endpoint? What does it look like? Is it meeting my compliance requirements? And then storing the answers to that question somewhere so that when you go back and need to have evidence or prove things out, you have the records from osquery across all of your endpoints to say, yes, we have 80 or 85% compliance across the last 6 months, and here's how we know. The technical bits on disk, osquery caches data using RocksDB, and it has two main parts. The larger one is osquery D, which is the background daemon that is what most people think of as the endpoint agent. That is running continuously, and it runs queries that you write and schedule on a schedule. osquery I allows you to run real-time and interactive queries. It's just a command line flag to osquery D, but it's a great way to write, prove out, and test the queries that you will want to run, have osquery D run on a schedule, because you can see if you're getting the results you expect or not. It allows you to deliver results to various destinations. You can dump it out to a file or a Unix socket. It allows you to stream data up to an osquery TLS endpoint, which is how it was originally designed. And recently, it's been extended to allow you to deliver data to Kinesis, Kafka, and various other endpoints. You can write a plugin for osquery to stream data to new places. Okay. So, CloudQuery is an open source extension to osquery released by Uptycs. It was announced at osquery at Scale. It is not the similarly named CloudQuery project that is its own sort of separate thing, taking the ideas of turning cloud data into SQL, but it specifically extends osquery to cloud infrastructure. As mentioned previously, it supports AWS, GCP, and Azure. As with osquery, it allows you to run scheduled queries in the background, which is probably how you will want to use it most, and write real-time queries, which is what we'll look at in the demo later, to be able to ask questions of your infrastructure in the moment. So some of the use cases, right? Resource visualization. What do I have in AWS? Monitoring configuration and drift. How is it set up? Is it how I expect? Is it time to redeploy, right? Is my infrastructure the infrastructure that I expect? Rather than waiting through AWS, right? Getting a report generated every so often via CloudQuery will let you take a peek at that over time. Again, going back to the idea of audit and compliance, were all of my resources in compliance for the last 6 months? Were they in compliance for the last 7 days, whatever that rolling window is? It also allows you to do investigation because you can ask real-time questions. What's going on in this instance? What's going on in this S3 bucket? What's going on in this user's account? Okay, so let's take a look and talk about kind of why this matters. We're going to walk through a hypothetical scenario here real quick. So consider the following sequence of events. So we've got a user who's got access to IAM credentials, and they log into an AWS account. Okay. The user then uses a trusted AMI instance. The user launches an EC2 instance from a trusted AMI. Upon booting, This EC2 instance runs an Ubuntu server, which has the permissions to mount an S3 bucket, which has sensitive data. The Ubuntu software utilities, which are running in the context of that EC2 instance, because the EC2 instance has been granted permission, can access that S3 data. Now, a malicious script launched by the user, which is running, again, in the context of the Ubuntu instance, runs a curl command. So a malicious actor gets access to this. The curl command then invokes a DNS lookup of a domain. That domain can have a reputation, right? You can take that domain reputation and send it out to, let's say, domain tools, for example. It then establishes the TCP IP socket. Again, that IP address can have a known reputation. And then it establishes an HTTPS connection, which can have a JA3 or JARM signature, right? These, all of the pieces in that connection can have a reputation, and because you have that data, you can enrich that upstream. The curl command then, once that connection is open, pulls the data from the S3 bucket and ships it out to your C3 server. Okay. So that above scenario outlines the possibilities where a malactor with credentials is able to masquerade and exfiltrate data. So for the first part of the interactions in that scenario, which is confined to AWS API data, CloudQuery provides relevant telemetry. You might look at things like the AWS IAM tables, right, which has the details about the IAM account that started the EC2 instance. There are a number of EC2 tables that can give you details about the instance. The configuration and access information about the S3 buckets, and the CloudTrail activity, which captures details like throughout that process, right? The user connecting with IAM credentials, the EC2 instance being launched from an AMI, and the actual run of the operating system that's doing something malicious. For the second part of the attack here, osquery, which is running inside the context of the virtual machine, right? osquery is for endpoints, CloudQuery is for all of your cloud data. We have the ability to capture telemetry at various stages of the attack that's happening inside the VM. So the process events table captures all of the processes that are running and the ancestor list, which can show the shell that was created due to the SSH login, the TTY that goes all the way back up to the init process. When the socket connection is established, the process socket events table from osquery can provide the necessary information to link the IP with IP reputation databases. The DNS and HTTP events tables can do the same thing for reputation databases for HTTP domains, and the URL information that can be joined or enriched with JA3 reputation databases. Additionally, if the file was copied, for example, if the file was copied out of an S3 bucket and to the actual endpoint before being shipped off with curl, you can access the process file events table to see all of the copy, move, open events that happened on the endpoint. So you can see that with being able to query the structured telemetry in both cases, you can watch the process of the attack as it progresses from the cloud down to the specific endpoint where that happened. Okay. So let's talk about what you can CloudQuery. So you can CloudQuery AWS. This is maybe a third or a quarter of the AWS tables that are in CloudQuery right now, and we are adding more all the time. EC2 image, EC2 instance, EC2 security group, lots of questions about IAM groups and roles. That's, again, these are representative, but by no means all of them. You can CloudQuery GCP, the compute disk, the compute image, the instance, the network, the storage bucket, similar to AWS S3. So you do need to write specific queries for the tables, but the data that comes back has very similar columns and rows, right? So you can look at similar information across multiple clouds. let's take a look at some examples, right? Because this is all a very sort of hypothetical pie in the sky. So let's talk about AWS S3 Bucket Compliance. This is from the CIS Amazon Benchmark 1.3.0. Ensure that S3 buckets are configured with block public access and ensure that all S3 buckets employ encryption at rest. So let's check and see. Here's a sample query that you would use in CloudQuery. You're getting the name and then the magic of SQL case. When the server-side encryption configuration is not null, meaning it's set, then great. Otherwise, we're going to raise the alarm. That comes down as a status column. And another case, getting information about the name of the S3 bucket to say it's enabled, it's disabled, we don't know, and the region code from the S3 bucket table. Okay. This isn't compliance, but from a BCDR and safety perspective, you will probably care about S3 versioning. Is S3 versioning turned on all of your buckets so that when you go to, say, one of your employees accidentally does something, not even malicious, and all of the S3 buckets get trashed, can you go back to a known good version? Again, name of the bucket, case when the versioning status is enabled, everything's great, otherwise there's a problem, and then what the versioning status is as a column from the AWS S3 bucket. In this case, we're ordering by name so that it's easy to see. You can, of course, use all of your SQL tricks. These are what I would consider sort of medium, low SQL select statements. How about password compliance, right? Is the IAM password policy set for all of your users properly? Does it require an uppercase letter, a lowercase letter, a symbol, a number, and a minimum length of 14 or greater? Well, in this brave new world, there's no trust, there's only verify. So we're going to get the minimum password length, the password reuse prevention, the lowercase characters, uppercase characters, require numbers, max password age. If all of those are true, then we have strong password policies. Otherwise, we don't. And this is a way to, again, take all of the data that you have about the password policies across all of your AWS accounts, and distill that down to a single answer to the question, am I compliant with this benchmark or not across all of the AWS accounts that I have? Okay. KubeQuery is another open source extension released in 2021, also announced at osquery at scale, and it takes SQL-based analytics and extends them to Kubernetes orchestrators. It has support for Kubernetes OpenShift, EKS, and GKE. The use cases are container security at an individual and pod level, monitoring config and security policies for your Kubernetes deployment, and of course, compliance. This is a daemon set that runs in Kubernetes. So rather than running KubeQuery as an actual something in your container, you would want to run osquery in each of your containers if you wanted to be able to ask questions with osquery. And then KubeQuery sits alongside and allows you to ask questions of your control plane. Okay. Now there's a missing piece to all of this, and that is generally that the logs, so all of the KubeQuery, osquery, and CloudQuery are going to be running as daemons somewhere, and they're going to be asking questions every 300 seconds, say. What does my environment look like using the SQL queries that you define? It's important to know that you have to take the data that comes back and ship that somewhere. You could leave it on the file system, but that doesn't really map for things like CloudQuery and KubeQuery, right? That might be fine for osquery if you're using a Splunk forwarder or you're shipping it off. But osquery was originally designed to use an upstream, what's called an osquery TLS endpoint, and that is sort of your aggregator. All of the various query agents that are registered across your fleet are shipping data up to usually an osquery TLS endpoint. So we've released a very, very minimal osquery TLS endpoint. There are lots of osquery endpoints, TLS endpoints out there. OS Control, Collide, now Fleet, And this is designed specifically for a very, very minimal bare bones kind of get you up and running, being able to aggregate all of your OS or star query results and ask questions of them, right? So this is a Lambda function. It persists log data that comes from all of your endpoints to S3 organized by day. It allows you to create rule and alert notifications using JSON logic. And it was, again, designed as a very minimal logging infrastructure for cloud, cube, whatever query. All right. I think that if I've done everything right, it's demo time. So let's give this a try. So I have a EC2 instance running in a cloud that has permissions to ask questions of an AWS account. We're going to run it in a Docker container. That's how it comes packaged on the GitHub page. And I've mapped AWS credentials and a logging directory in. We're running osquery I, which is the interactive command line version. I'm just gonna show you some sample queries, and I'll actually pull ones from the slides previously so you can see how that works. So we're in the interactive shell, and I'm going to paste the query here. So we're going to get the information about server-side encryption. And I'm going to start that now because it is doing a real-time query and it is asking across all of the AWS accounts. It can sometimes take a minute or two to return data, which is the sticking part of the demo. So I've asked both of those questions, and we'll see where that comes back. In the meantime, do we have questions that I can answer?
Yeah, it's a great time to drop one in. So I'm just looking through the Q&A here. So someone asked about how much data this can process. Have you seen kind of small to mid-sized businesses in the past? That data works fine. But if you get into a large enterprise org, and you're dealing with like gigs and gigs of resources, have you seen this at scale in that kind of environment?
So that's a great question. I personally haven't worked with this at sort of, enterprise or like Fortune 500 company scale. So I can't speak to that directly. What I would say is that there was a conference earlier this year, osquery at Scale 2021, and there are a number of talks about scaling osquery out to sort of larger and larger orgs and what that looks like. I don't have a good, I guess what I want to say is I apologize. I don't know that I have a good or easy answer for like what the maximum limit for this is. You are going to run into sort of the usual scaling problems where, you might need to sort of partition out some of your AWS accounts, like CloudQuery is asking these questions and of these number of AWS accounts, and another instance of CloudQuery is asking questions of these AWS accounts. And no, I don't have an idea of what that number is either, but I am happy to ask some of our engineers who work with this a little more directly what that is and get back to folks.
Perfect. Yeah, it's always hard to guess, right? You never quite know at that enterprise level, but if you ever find it out, we'll hit you up for some contact info, or you can drop it in the Slack channel if you get it within the next 24 hours.
Sounds great.
Let's see. We've got another question. Someone asked, are there use cases for osquery specifically if you already have an endpoint detection and response solution? Do you think there's a use case for both where you would want to use both options?
So I think the answer to that depends on sort of how good your EDR or XDR solution is. osquery is great at being able to get you a lot of data about endpoints, probably almost as much, if not more, than your EDR solution, depending on what that looks like. We like it because it's open source, and we also like it because it's extensible, as this sort of demonstrates. You can plug more things into osquery easily, so it's a great foundation to build on. especially if you are a larger org and you are running or you're running more things in-house. Being able to manage osquery, configure it to do exactly what you want, extend it with the things that you and only you need. You can, I mean, as an example, you can go in and rip out half or 2/3 of the tables in osquery if there are only some things that you need. If you were going to look at a cutover or something like that from an EDR solution to osquery, nobody likes hearing, oh, look, one more agent. But because it does have a built-in watchdog, and because you can kind of tune what you do and don't care about, it's great to sort of get questions answered that maybe your EDR isn't, without adding a whole lot of additional resources. I'm going to switch back to the demo real quick. I hope my screen's still visible. So that did take a minute to return. We're always working on tuning that. And again, it does kind of depend on both the questions you're asking and how many AWS resources you're looking at. But the bucket encryption came back, looks good. The buckets that we have in US East that were made for this demo do in fact have encryption enabled. Unfortunately, they don't have versioning enabled. So if I did something really terrible, that's not going to be recoverable at this point. I guess I'll have to talk to my AWS ops team about that. I'm going to run one more query. I don't know if it will complete before we're at time, and I do want to respect that, but I will get it going. And maybe one more question from the chat.
Yeah, absolutely. We've got another question that came in. Again, it's about scale. This would be related to, how many AWS accounts do you think is the upper bound of running a query against for their resources?
Again, not something I have a specific answer to at this point, and I would rather say I don't know than steer you wrong. We're seeing, I don't know what the upper bound that we're even working with is right now. Let me, again, see if I can get a more specific answer to that and find out. And so looks like the demo came back. And to no one's surprise for this demonstration, we have not configured strong password policies. All right, by my timer, I'm at 30 minutes. I'm gonna stop screen sharing and hand it back. Great.